Static electricity is a fascinating and everyday phenomenon that occurs when there is an imbalance of electric charges on the surface of objects. To understand it, we need to dive into the behavior of atoms. Atoms, the building blocks of everything around us, are made up of three particles: protons, neutrons, and electrons. Protons and neutrons sit tightly together in the nucleus, while electrons move around the nucleus. Electrons are negatively charged, and when they are transferred from one object to another, static electricity is created. This transfer of electrons happens when two objects come into contact and then separate. For example, when you rub a balloon against your hair or a wool sweater, the friction causes electrons to move. The balloon gains electrons and becomes negatively charged, while your hair loses electrons and becomes positively charged. Opposite charges attract, which is why your hair stands on end and sticks to the balloon. This simple demonstration is an easy way to visualize how static electricity works. The key to static electricity is that the charges remain stationary, or static, until they are discharged. This happens because the materials involved are insulators, which do not allow electric charges to flow freely. However, when a pathway is provided, such as when you touch a doorknob after walking on a carpet, the stored charge suddenly moves, creating a tiny spark. This discharge is the shock you feel and is a quick equalization of the charge imbalance. Static electricity is not just a quirky phenomenon you encounter in daily life, it also has significant applications and implications. In industrial settings, it can be harnessed for useful purposes like air purification, where static charges are used to attract and trap dust particles. However, static electricity can also be dangerous. In environments where flammable gases or liquids are present, a sudden discharge could ignite an explosion. To prevent this, grounding and other safety measures are used to ensure that charges do not build up to hazardous levels. Interestingly, static electricity plays a role in nature too. Lightning, one of the most powerful displays of static electricity, occurs when charge imbalances build up in clouds during a storm. When the difference between the charges in the cloud and the ground becomes too great, a massive discharge occurs in the form of a lightning strike. This is a dramatic example of the same principles that cause a tiny spark when you touch a doorknob, just on a much larger scale. Static electricity is a reminder of the invisible forces that govern our physical world. It illustrates how even the tiniest particles can create effects that are not only observable but also impactful. Whether it's a fun experiment with a balloon or a vital component in industrial processes, static electricity continues to capture our curiosity and demonstrate the incredible power of basic scientific principles.